Hello and welcome back. We're going to be doing some more word problems today. I've actually been thinking a lot about word problems. One of the things that I like about word problems is that they try to make them into situations that you might see yourself in. I actually have a word problem for you guys tomorrow. I'm going to save it for tomorrow. That is one that is like a real life. It is a real life word problem for me. It's something that I've been trying to figure out and make sure that I can set a reasonable goal for myself. But I'll get more into that tomorrow. You'll see the word problem and see what my goal is. So let's go ahead and look at today's lesson. It's going to be solving more word problems. Module 7, Lesson 2. We're going to talk about, in addition to using a variable or a letter to represent the unknown, we're also going to talk about how there's different ways that we could solve a problem. So we're going to be looking at a problem a couple times and using different methods to figure it out. First, we're going to do a little warm-up. And for this warm-up, we're just gonna name shapes. I was actually listening to my wife teaching some lessons. She's talking about shapes with her students. So I know you guys have done this last year. Let's go ahead and look at this. We have a shape with 3 sides, 3 angles. And the root word for 3 is tri. So this is a triangle. Then we have 4 sides with 4 angles, but not all of the sides are the same length. Opposite sides are parallel to each other, and opposite sides are the same length as well. This is a rectangle. Now we have a shape. Not all the sides are the same length. Looks like there's 5 sides, 5 angles. The angles are all different. These angles are bigger than this angle. This angle right here is much bigger than this one. 5 sides. This is a polygon. We want to be more specific though. A polygon that has 5 sides. The root word for 5 is pent. So this is a pentagon. And then finally we have another polygon, shape with multiple sides that's closed. This has 6 sides, and the root word for 6 is hex. So this is a hexagon. For these problems, we're going to be using the read, draw, write process to solve. We want to use a letter to represent the unknown. Now, the nice thing about using these variables is that it helps us to lay out the information in another way. And if you have been practicing reading and writing in math, then this will just be like helping us plan out how we're going to solve it, just like working with English. So it says Leanne needs 120 tiles for an art project. She has 56 tiles. If tiles are sold in boxes of 8, how many more boxes of tiles does Leanne need to buy? I'm going to take that information and I'm going to go ahead and write it down. She needs 128. That's going to be the total number of tiles that she needs. Sorry, 120. And she already has 56 tiles. And then she needs some more. And we're going to use the letter N to represent how many more tiles she needs. And then once we know how many tiles that she needs, we know that they're sold in boxes of 8. So however many she needs, we need to know how many boxes in each box has 8. So anywhere we see the letter N, it's going to represent how many tiles she needs. Anywhere we see the letter B, it's going to represent the number of boxes, and we can always replace them. I'm going to use tape diagrams to help me on this one. I love a good tape diagram. So for a tape diagram for this first problem, we're going to draw out our piece of tape. The total amount, the whole length of this tape is 120. And then part of this tape is 56. And the other part of this tape is N. And when we put them together, it gives us 120. So I can take away from 120 to find out how much this is. I can figure out what number I would add to 56 to get to 120. Let's go ahead and do subtraction though. So 120 minus 56, I'm going to need to make an exchange. So this, I'm going to take a 10 and turn it into 10 ones. 10 minus 6 is 4. 1 minus 5 I can't do, so I'm going to make another exchange. So now I have 0 hundreds and 10 more tens, so 11 tens minus 5 tens. 64 is going to be equal to n. Now, anywhere that I see an n, I can cross it out and I can put 64. Right here, I can put 64. Right here, I can put 64. And that's the advantage of using the variable. So normally, if I'm showing my work, I'm not going to erase all the n's. But in this case, I'm going to erase this n and this n so that we can see them. I'm going to use a different color. 64. 64. Now I need to figure out how many boxes she needs. And I know that it's going to be 8 times something that will give me 64. So let's go ahead and draw a tape diagram for this. And when we're doing a tape diagram, in this case, we know how many are in each group. Each group has 8. That represents a box. We know that we need a total of 64, so we can put that down here, 64. But what we don't know is how many groups. How many times do we need 8? And that's our unknown, B. So now we're going to try to figure it out. And what we can do is we can just count by 8s until we get to 64. So we have a good song for that one. 8, 16, 24, 32, 40, 48, 56, 64. Stop. How many times did I count by 8? Counted 8 times. So I would need 8 groups of 8 in order to get there. So in this case, B is going to be equal to 8. And I know that because we ended up doing 64 divided by 8. We saw how many times we would count by 8 to get there. So this is just showing some extra work. Now the last thing though is we need to redraw and write. So we're going to write our answer in purple today. We want to make sure that we're answering the right thing. So it says, how many more boxes of tiles does Leanne need? And we're just going to reword this. We're going to say, Leanne needs, I'm going to leave it blank, more boxes. And we're going to talk for a second, because we had 2 different unknowns. Just find me on that. We had 2 different unknowns. We had N and we had B. We want to know which one represented the number of boxes. And we used N was the number of tiles that she needed. B was the number of boxes. So we're going to use whatever B equaled. And we're going to add that in here. Leanne needs 8 more boxes. That's our final answer. We're going to do the same problem, but we're going to do it just a little bit different. So again, Leanne needs 120 tiles for our project. She has 56. If the tiles are sold in boxes of 8, how many more boxes of tiles does Leanne need to buy? In this case, we're going to be thinking, okay, the total amount is 120. I'm going to use a number bond for this. So this is the total amount that she needs. She already has 56. So what's the other part that she needs? In this case, it's an addition number bond. And so our missing value right here, we can use a letter to represent the unknown instead of a question mark or leaving it blank. And again, let's use the same letter. Let's use the letter N for how many more tiles that she needs. Now, we already figured this out in the last step. We figured out that it was 64. So I'm just going to rewrite that. So the work would look pretty much the same. I'm just modeling it a different way when I'm doing my drawing step. And then we have this problem over here where we know that there are 64 tiles. And we're going to do a number bond again, but this time we're going to do a multiplication number bond where each piece is one box. So the question is, how many more do we need? We're going to have a ton of these little legs. So it's going to be an addition again because we're doing repeated addition. And I can count kind of a cumulative total. So I have 8. Another 8 makes 16. And you don't need to put these plus symbols in. I'll stop after this one. 24. 32. 40. 48. 56. 64. All right. So I now have groups of 8 that equal 64. How many groups do I have? 1, 2, 3, 4, 5, 6, 7, 8 of them. And so the number of boxes that I need is going to be equal to 8. Now I didn't write out my equations on this one like I did on the first one. I just wanted to show different ways of drawing it. Because there's lots of different ways that you could draw it. You could, if you really wanted to, draw all the tiles. That would take a really long time. You could draw boxes instead. You could, I don't know, there's any method that you want really to solve this. But we want to make sure that we have some sort of drawing. We want to make sure that we read it so that we know what we're answering. And we want to write out the answer. We talked in the past about how you can write out your answer before you even start working on the problem. And so if I were to do that, I would just look at this. How many more boxes of tiles does Leanne need to buy? I would just start writing Leanne needs to buy blank more boxes. And that's kind of what we did. And then we figured out which letter or which number we needed to put in here using our variables. Word problems today, we did the first one together. You keep working on them. If you want to challenge yourself, try to model these in 2 different ways. Maybe you'll use a tape diagram, maybe you'll use a number bond, maybe you'll use a picture, maybe you'll use skip counting. Just try it out, try different methods, see which one works best for you. And there's really no wrong way to draw it or model it. You just need to show it in some way and then practicing that, writing out your answers. Okay. I'll have a word problem for you tomorrow, a real life application of something going on in my life. But until then, good luck with your math. Let me know if you need anything, and I will see you tomorrow.